Monetary policy is the central bank's way of steering the economy, much like a thermostat controls the temperature of a house. Price stability, keeping inflation low and predictable, akin to keeping the thermostat at a comfortable temperature so that the house does not get too hot high inflation or too cold deflation. Stable prices protect savings and encourage long-term investment. Full employment, aiming for as many people as possible to have a job without causing inflationary pressure. Think of a factory that wants to keep all its production lines running but not overload the power supply. Similarly, the economy should use its labor resources efficiently. Financial stability, preventing banking crises and market crashes. This is like making sure the house's electrical wiring does not overload and cause a fire. A stable financial system ensures credit flows smoothly to households and firms. All three goals are interlinked. High inflation can erode purchasing power, which hurts employment. A banking crisis can instantly raise unemployment and push prices down. The central bank balances them by adjusting the cost of money. Central banks have a small toolbox, and the most frequently used instruments are policy, also called short-run interest rate, the rate at which the central bank lends to commercial banks overnight. For example, the federal funds rate in the United States. Raising the rate is like tightening a screw. Borrowing becomes more expensive, demand falls, and inflation cools. Lowering it loosens the screw, stimulating spending. Discount rate, the rate charged when banks borrow directly from the central bank's discount window. It works as a safety net. A higher discount rate discourages banks from turning to the central bank, signaling confidence in market funding. Reserve requirements, the fraction of deposits banks must keep as liquid reserves. Raising the requirement is like asking a grocery store to keep more stock on the shelf. It reduces the amount banks can loan out, contracting the money supply. Lowering it frees up more funds for lending. In practice, most modern economies rely heavily on the policy rate, using the other tools only in crisis periods. Explanation: the IS-LM model captures the interaction between the goods market IS and the money market LM. IS curve investment saving, derived from y equals c of y minus t plus I of r plus g plus nx, a lower interest rate r raises investment I, shifting the IS curve right, meaning higher output y. LM curve, liquidity money, derived from money market equilibrium m over p equals L of y comma r, higher r reduces money demand L, shifting LM left, lowering y. Quantitative impact. Start with the linearized forms. IS colon y equals a minus BR and LM colon y equals C plus DR, where B and D are greater than 0. Solve for equilibrium y star and r star. Y star equals open parentheses a D plus BC close parentheses divided by open parentheses B plus D close parentheses. And r star equals open parentheses a minus C close parentheses divided by open parentheses B plus D close parentheses. A change in the policy rate delta R sub policy moves the LM curve vertically by delta R equals delta R sub policy. The resulting change in output is delta Y equals negative open parentheses BD close parentheses divided by open parentheses B plus D close parentheses delta R sub policy. The term open parentheses BD close parentheses divided by open parentheses B plus D close parentheses is the multiplier effect of the interest rate change. The larger the sensitivity of investment to R, big B, and the larger the sensitivity of money demand to R, big D, the bigger the impact on output. This simple algebra shows why a 1% point cut in the policy rate can move real GDP by several percent points in a highly leveraged economy. Explanation: the Taylor rule gives a systematic way for a central bank to set its policy rate based on inflation and output gaps. The most common specification is I sub t equals r star plus pi sub t plus 0.5 pi sub t minus pi star plus 0.5 y gap, where I sub t equals nominal policy rate. R star equals presumed long-run real interest rate, often 2%. Pi sub t equals current inflation rate. Pi star equals inflation target, usually 2%. Y gap equals output gap equals y sub t minus y potential divided by y potential. Calibration example. Assume r star equals 2%, pi sub t equals 3%, pi star equals 2%, y gap equals 1%. I sub t equals 2 plus 3 plus 0.53 minus 2 plus 0.51 equals 5 plus 0.5 plus 0.5 equals 6%. So the rule suggests a 6% policy rate. Policy implications. When inflation is above target, the rule pushes rates up, automatically anchoring expectations. When the economy runs below potential, the rule calls for lower rates, providing stimulus. The coefficients 0.5 reflect the central bank's willingness to react. A higher coefficient means a more aggressive stance. Real-world use the Fed's former Taylor-style guidance and the ECB's rules-based approach both stem from this formula. When a central bank changes its policy rate, the effect ripples through the economy via several transmission channels. Interest rate channel: lower rates reduce the cost of borrowing for households, mortgages, car loans, and firms. Capital investment: example, a cut from 5% to 3% can make a $200,000 mortgage payment drop by about $150 per month, freeing income for consumption. Exchange rate channel: a lower domestic rate makes the currency less attractive to foreign investors, causing depreciation. A weaker dollar makes U.S. exports cheaper abroad, boosting net exports. Analogy: a sale price tag depreciated currency draws more shoppers, foreign buyers. Asset price channel: lower rates raise the present value of future cash flows, lifting stock prices and real estate values. Higher wealth increases consumer confidence and spending. The wealth effect. Credit channel: 2 sub affects bank loan channel: lower rates improve banks' balance sheets, encouraging them to lend more. Balance sheet channel: lower rates raise asset prices, improving borrowers' balance sheets so they qualify for larger loans. All channels act together. The dominant channel can differ across countries. In Japan, the asset price channel is crucial, while in emerging markets, the exchange rate channel often dominates. Two major monetary policy frameworks compete on how to anchor expectations. Inflation targeting. The central bank publicly announces a numerical inflation goal, for example, 2 plus or minus 0.5%. Policy is then adjusted to keep actual inflation close to the target. The rule-based nature creates transparency. Markets can predict future rates, reducing uncertainty. Example: the Bank of England's 2% target since 2003. Monetary aggregate targeting. Instead of focusing on inflation, the bank controls a money supply variable such as M2 or the monetary base. The idea is that a stable growth rate of the aggregate will eventually yield stable inflation, the classic monetarist view of Milton Friedman. Historically, the Fed used M1 targeting in the early 1980s. Performance assessment. Clarity: inflation targeting, high, simple number. Monetary aggregate regime, low, many aggregates, measurement issues. Flexibility: inflation targeting, high, can react to shocks. Monetary aggregate regime, low, must keep growth of aggregate steady, may conflict with output goals. Empirical track record. Inflation targeting, generally successful in advanced economies post-1990s. Monetary aggregate regime, less successful, many countries abandoned it after volatility in aggregates. In practice, most modern central banks combine a primary inflation target with a secondary price level or average inflation commitment to handle periods of persistently low inflation. Mundell-Fleming model extends IS-LM to an open economy with international capital flows. The key equations are: goods market, y equals c of y minus t plus I of r plus g plus nx of EYY star. Money market, m over p equals L of yr. Interest parity, perfect capital mobility. R equals R star plus open parenthesis E superscript E minus E close parenthesis divided by E. Fixed exchange rate regime. The central bank must intervene to keep E constant. A domestic rate cut lowers R below the world rate R star, causing capital outflows. To maintain the peg, the central bank sells foreign reserves and buys domestic currency, which reduces the money supply, shifts LM left, and offsets the initial stimulus. Hence, monetary policy is largely ineffective. Fiscal policy becomes the main tool. Flexible floating exchange rate regime. The same rate cut makes R less than R star, leading to capital outflows. Domestic currency depreciates, E rises. Depreciation improves net exports, shifting the IS curve right, reinforcing the expansionary effect. The LM curve stays where it is because the central bank does not intervene. Real-world illustration. In the early 2000s, the Eurozone's fixed-rate arrangement limited the European Central Bank's ability to counteract asymmetric shocks, whereas the United States Federal Reserve could use rate cuts to stimulate the economy thanks to a floating dollar. When the policy rate hits the zero lower bound (ZLB), conventional cuts can no longer lower borrowing costs. The economy may fall into a liquidity trap, where people hoard cash despite low rates. Central banks resort to unconventional tools. Quantitative easing, QE. The central bank buys long-term government bonds or private sector assets, injecting reserves directly into the banking system. In the basic ISLM picture, QE shifts the LM curve right higher M, lowering R even when the policy rate is zero. Example, the Fed's QE1 to QE3 programs from 2008 to 2014 increased the monetary base by over $3 trillion. Forward guidance. The central bank publicly commits to keeping rates low for a future period. For example, rates will stay near zero until unemployment falls below 6%. This shapes expectations of future R, reducing the term premium and effectively lowering the long-run interest rate even when the short rate is zero. Simple model illustration. Use the basic equation R equals I minus pi E Fisher equation. If the central bank promises that pi E will stay at 2% and the nominal rate I equals 0, the real rate R equals negative 2%, providing stimulus despite a zero nominal rate. These tools rely heavily on credibility. If markets doubt the commitment, the